Okay, so the last thing to kind of close the chapter of like purely 2D operations and like fragment shader is to kind of show how to convert a shader from Shadertoy, which is like this big online repository where like all sort of crazy people do crazy things with shader, and how to kind of have them running inside of TouchDesigner. So it's more an exercise in kind of debugging. I'm not gonna kind of deconstruct what's going on. So we're gonna create a new base and just call it Shadertoy and go inside. And so it looks like this.
Oh, just like check that use previews?
Yeah.
Okay.
And so for each one, like you get the code, and you get the kind of the rendering. So I would raise your attention to always check what kind of license come with the shader, and kind of respect the rights. Like so usually, so if you just Google that. So people are like, it's great that they share all that, but it doesn't mean you can just like kind of take it and do what you want with it. So for example, the one I was just checking, you can share it and adapt it, but you always have to give credits, and you can't like use it for commercial purpose. So most of them have.
This is like one of the most intense ones.
Yeah. Okay, so I think, yeah, I wanted to show, so this one is like purely procedural. So a lot of these shaders, what they do is kind of like create geometry using Perlin noise, and then they kind of handle the rendering using ray tracing. So instead of like using regular geometry and like the regular OpenGL pipeline, they just do like kind of create their own render engine inside of the shader. So we're not gonna get too much into that, but what I want to show you is, so if you downloaded the kind of the folder I shared earlier, there was, I was just, oops, not this one. So you can also drop down a text that and point it to the file. And then you do pulse. So it's this one. So you can see this one is also a Creative Commons attribution and commercial share alike. And so it's like similar technique. It's like kind of retrace this this sphere using transparency. And then I'm gonna create a new GLSL top. And now what I'm gonna do is I'm gonna replace the pixel shader with this new text. And now we're gonna see a lot of errors. So a lot of it has to do with undefined variable. So it's like, and these are the equivalents from the built-in TouchDesigner variable, except these are the ones. And now what I'm gonna do that are available for Shadertoy is I'm gonna replace. So if you go to the Shadertoy website and you click Shader inputs, so these are all the uniforms that Shadertoy make available to use in the shader. So you can see I resolution is the viewport resolution, I time is the shader playback time, so on and so forth. So a big part of getting the shader to work is just to kind of create them in the code. Sorry, this one. Okay. So all the way at the top. So I'm just gonna like go through the errors one by one. So I'm gonna create a uniform. So we know it's time, so it's just gonna be a single value. So we're gonna call it alt I time and compile. So this one is gone. So we know resolution is gonna be a vector 2. So it says it's a vector 3. I think it's only using the first two coordinates though. So let's do a vector 2.
You just copy paste
And then iMouse, I think. Copy paste the whole block. Yeah. That's fair. I think there's like a bunch that is not using, but
There are a bunch of those.
so I think
It's only using iTime, iMouse, and iResolution.
yeah. So and iChannel 0 is something else.
Yeah.
So I think just for the sake of the exercise, let's just do this one too. I'm gonna say vec3 iMouse. Yeah, because this thing is like with the mouse, you can if you click and drag, you can rotate the camera. And then there is this last one, which is iChannel 0. And iChannel 0, it's not a uniform, but it's a sampler, so a texture. And so one way to yeah, so you can see it's used with the texture function. So if you don't want to kind of go in and replace the code, so first we're gonna connect a movie file in. And what we can do is use a macro. So a macro, so it's going to be hashtag define. And then you're going to say iChannel 0, and what you want to replace it is std to the input 0. And what it does is before compiling the shader, it's going to replace in the text every instance of iChannel 0 by std to the input 0. So that can be a quick way to, if you want to do shader that like work on multiple platforms, you can like use defines to kind of switch between predefined uniforms.
Sorry.
Oh yeah.
Oh.
So 97 texture iChannel.
So what is STD to the inputs?
So std to the inputs is referencing the texture connected to the first input.
Okay.
It's one of the built-in. It's one of the built-in uniforms that Touch provides for you.
And the shader works with. Oh no.
No, it doesn't. Okay, and so now the next one is like a little more cryptic, because it says, okay, line 97, it's expecting a vector 3, and we're giving him a vector 2.
Yeah.
So if we go there, and so you're like, okay, RD are the coordinates, and RD is a vector 3. And previously, we've learned that to sample a 2D texture, we want a vector 2. But if you go back to Shadertoy, So the thing is, I channel 0 it's not a regular texture, but it's a cube map. So a cube map is a special type of texture to kind of describe an environment. And the thing is that in TouchDesigner, so if we go check the help cards, I still have it here. So there are different types of samplers. So sampler 2D is just a regular texture. But then you have a sampler cube, which is a cube map texture. And in that case, instead of the uniform being called std2d inputs, it's going to be called std cube inputs. The first thing is first we want to actually provide a cube map. So how do you create a cube map? So we're going to load we're going to load the Palace of Fine Arts 360 design, which is an environment map. But then this is a special format of environment, and we want to convert that to a cube map. And so for this, you can use the projection top. So this particular format is called equirectangular. So input is equirectangular, and output is cube map. And so that's what a cube map looks like. And if you middle click, you're going to see touch say, that's a cube map texture. And so these are like 6 sides of a cube. And if you kind of like imagine like reconstructing the cube, it's like a cube with this environment. So now we can connect that here.
Sorry, can you just go back to, no, you have it.
So
I just wanted to see the projection top where you had the parameters.
And so now the error we're getting is undefined variable std to the inputs. And that's because what we connected is a cube map. So what we need to do is to change, is to replace std to the input 0 by std cube input 0. And now, so now the other errors we're getting is that, so we got rid of all the errors we had. It compiles successfully, but we still get like linking errors. And this error is because if you, so all of these are kind of custom function, but then you're gonna see this main image function. And so instead of main image, we want to use just a regular main function. So we're gonna get rid, I'm gonna comment it now. I'm just gonna type void main, which is what we saw at the very beginning. And now it says it doesn't know what fragment coordinate is, frag core is. And so frag core is something that's provided when you write in Shadertoy. And it's basically the pixel coordinates. And so the nice thing is there is a kind of built-in uniform called GL frag chord. So we can just say vec for frag coord equal, I think it's this. So now we're kind of defining what frag chord is. And the last thing it's complaining about is an undefined variable frag color. And that's because we also need to define the output. So we're gonna copy paste the out just below the main. And now it compiles successfully. So it's black and it's giving a warning. And that's because we haven't actually defined any of the uniforms. And so one thing I don't use very often, and it came to my attention, there is this load uniform names you can click. And when you do it, then it automatically populates the uniform names with what you typed. So it kind of prevents to like on making any typo, and it's convenient. It doesn't reorder them in like the way of the code. If you like kind of wrote some and then erased some, it's like, but it can still be useful. And so resolution is the resolution of the top. So let's do 1220.
So how do you make it populate automatically?
You click the load uniform on the first page. So for it to work, it's doing it post-compilation. So if you're declaring uniforms but they're not used in the code, it's not going to use them.
Okay.
They get discarded. And it's magic. Now we kind of see our thing.
What resolution did you put in there?
I put 1280 by 720. And the thing is, you want that to match the actual resolution of the. So in custom resolution, what you want to do is to. Yeah, and now you have like a correct aspect ratio thing. And then what I can do is I can. So there is a mouse chop, which kind of gives me a mouse coordinate. I don't think it's gonna match, but we can see. Let's see what happens if I connect.
They're just looking for, I think, X, Y, Z. Or there's a Z.
Yeah, X, Y. ZW is the click, and XY is the. Okay. So I think we can say. We can try this. Yeah, it's doing a little something, so I think it's like needs to be scaled. Yeah, and so now I can like control the rotation.
How did you link that?
So there is this chop called mouse in, and then I multiply by 500. And then either you can so create an export. So you're gonna click the little viewer, and drag and drop on the X and Y. Or you can do the Python expression method and do OP quote, the name of the operator, bracket 0 and bracket 1 for like the first channel and the second channel. I'm gonna do it too. Sorry, just gonna do this and then.
Yeah, yeah.
Yep.
Could you load the things on here? I don't have that button.
Oh yeah, so it seems the button is new because some people don't have it. So this button, load uniform names, it seems it's fairly new because
I need to update the version.
yeah, out of curiosity, if you go to the which version do you have? Oh yeah, so you're 15.400. So there's been like after like 23 something, there's been like a couple of new things.
Okay.
Yeah. To show you. Yeah, if you click the, oh, you don't have it. But yeah, I'm like 24 or 10. And so now if you have like a fast, so this is like a lot more intensive than like all the small shader we've done. So you can see my GPU cook time is 5 milliseconds. Well, before like everything was point something. And the bigger the resolution, the slower it's going to be. Because the code is executed for every pixel. Just going to try it quickly. If I do, oops, define resolution. Where is it?
Yeah.
Okay. So, okay.
You have this for losing money to.
Oh, I thought you said.
Oh, right. So, if you want to get those files that are really good is. All right. So, you can only assign one float here and another float here.
And
so you're looking at uniform. So this refers to the variable and the GLSL, not the value itself. Value is down here.
and just
We're going to name that
just a quick update about
GLSL. Okay, so
about the resolution. So a clever way to do things.
and there you did what you did. That's correct. First one. No, that would still be 0. No, you're right.
Is instead of declaring a uniform for the resolution, you can use the built-in variable provided by Touch. So what I did is I commented out the high resolution vector, and I used another macro. And what I used is utility output info.res.zw, and this contains the resolution of your top as set on the command tab. And this way, you don't need to like have these two sets of value. It's always going to use what you have here. So if I do,
Oh, so the cube map is just for the background.
so just to show that macros are like a kind of powerful way to edit.
Almost Yeah, that's what I'm saying.
It keeps you to have it to define it in the uniforms.
Did you change the?
It's just using the actual resolution of the top. So it looks like that. So I think it was like part of a contest to do a very short shader that gives interesting result. So when you like reload it, it starts gray, and then you kind of have these emergent swirls that appear. And what we see here is there is a tab called buff A that stands for buffer A, and in the channel 0, so A means for buffer A, so it basically takes himself as an input. And so the way we can do that in TouchDesigner is using a feedback top. So in TouchDesigner, we're gonna, so this is the code from the shader. So I'm gonna create a GLSL top. And I'm gonna point the new pixel shader to it.
Did you copy buffer A into that text? Is that what it is?
I copied buffer A. So image, I'm gonna skip it. It's just like remapping the. You're just remapping the output from to a new range to display. I mean, we can add it, but it's not the main part. So yeah, this is the part we're interested in.
So you got rid of whatever was there. Oh, you just opened a new text.
Yeah. So the first thing is this one is a little, yeah, it's quirkier because the variables are renamed. So like C is the output color. So I'm gonna, just for the sake of readability.
Where did you get that? Is that linked somewhere?
Yeah, if the file doesn't load, if you like hit pulse, it should. So we're kind of gonna do the same as we did before. So kind of replace the main function. We use the out qualifier, vec4 frag color, and void main. Or actually, since it calls it C, maybe we'll just call it C to like do the minimum of work. So C is the color we're writing to. And then, so U was the fragment coordinates. So we're gonna say vec for U equals GL frag coord 19, maybe it's and 12. And then, so it's already using a macro to kind of shorten the code. So we're gonna directly replace, in the macro, we're gonna replace I channel 0 by std 2d input 0. And for I resolution, we can use output info dot res dot zw. Ta, ta, ta. Oh yeah, of course it's UTD output info.
What does S and U stand for?
Sorry.
What does S stand for in front of STD to the inputs and U?
S for sampler
Oh,
and U for uniform.
oh,
So yeah, so it's consistent. If you like write your own, it's recommended to use that too. Okay. And so now, what we want is to do a feedback loop. So I created a new constant that is black. Then I'm creating a feedback top. I'm gonna pulse it again so it's black. Gonna connect it to the first input. And now it's yeah, and now what we need to do, so now I've connected a sampler 2D to the first input, every error is gone. And now to make the feedback work, we need to point the null one, which is the output of our shader, to the target top in the feedback one. And now it's working. So what's happening is every frame, the code inside the shader gets executed, and the result is going to be fed back at the next frame as an input. So any variation is just going to get amplified again and again, and then based on the code and what is going on, you get like all sort of behavior.
I'm getting a weird syntax here.
So yeah, the thing is if you use macros, it makes the code harder to debug, because then the error is like not where you expect it to be.
Oh, so it's just a black constant that you have into the
Yeah,
feedback?
it's just a black constant that magically turns into color.
Where did you put this block of code?
I didn't use it. So if you want to use the second block of code, it would go after. It would go here, and because you can see this one also has the buffer A as an input, and you would just
Doing something. I definitely don't see any color.
didn't change anything in the feedback. You might want to restart.
yeah, so I'm just replacing it here, but
Oh, okay.
What'd you do to get these ripples?
yeah. So this piece of code only brightens the. So yeah, so now and then it's going to be always the. Even if you have like multiple buffers, you kind of have to look what's going into what and maybe make multiple feedback loops, and it gets like harder and harder, but that's like the basic. And And the kind of nice things with this feedback things is if I put down a transform inside a loop and I do a 2-degree rotation, that's even like too much. But you can do like, you can add other operation and it's still gonna.
Question, Vincent. There's some attributes here for C, which is G bar. Is that just rearranging RGBA?
Yeah. G bar is just rearranging RGBA.
What is CWZ?
It's just rearranging the last 2 coordinates.
The last 2 coordinates?
Because instead of RGBA, you can also use X, Y, Z, W.
Uh-huh.
So, and STPQ. They're all the same.
They all stand for the same
Yeah.
values that we talked within.
So if I replace WZ by a B, it's gonna be the same. Yeah.
So what do these letters say?
It just stands for the 4 components of the vector.
Right, so WZ stands for the first 2 components. What is the index of the components that it stands for?
It's X, so it's, yeah.
Oh, X, Y, Z, W.
So ZW are the last 2 components. Yeah. Yeah, I think the idea is when you're dealing with the color, you want to use the RGBA stuff. And when you deal with position, you want to use XYZ. So it makes
You said
sense.
there's also
STPQ.
What is that used for again?
So that would be more for UV coordinates.
Right.
It's like a different, yeah. But it's all the same, so.
Makes sense.
And if you want to reset the feedback, you select the feedback top, and you can pulse. And when you pulse, it's gonna use the input, and then like start looping again. Yeah. So for people who are not so familiar with feedback loops, so just to show, if I put a rectangle. So I'm gonna remove the, yeah. So the transform gets applied once, and then again and again and again. So that's why you see this, because if so my transform is like a really small rotation and a really small scaling, but frame after frame, I just take the transform input and I apply the transformation again. So the deformation gets amplified. So that's what the feedback means. Because these values are not animated, it's just the same that gets applied again and again and again. So anyway, just to, and then we can like, kind of. So feedback, you can do kind of a nice one in the palette if you don't know it. In the image filter, I think. You have this thing called feedback edge. And so I'm just gonna do like a circle. And so what it does is like does a bunch of operation to using edge and scaling, and you have like a bunch of control. And this is done just with regular operators, but you could like kind of do the same with just one GLSL. So that's kind of like a fun one if you like this kind of effects. You can. . in my humble opinion, it's been overused, but it's good fun.
Vincent, another question.
Uh-huh.
So we have we define the gel frag coordinates x, y. U then has two values. And then underneath it, it's c equals to u, y, 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 x. How does that get cast from two values to?
Yeah, so here it's actually not used, because it's, oh yeah, here it's used, okay.
Yeah, where it says item.
So what it does is it's just a way to assign C. So if I had, let's say, if I had, the the easiest way to kind of understand this kind of thing is just to like make a small test. So I'm gonna do a color that's a vec4, and it's 0.1, 0.2, 0.3, and 1. And I get, yeah, I'm just gonna do float. So you can see RGB is 0.1, 0.2, 0.3.
Yeah.
And now I'm gonna do color equal color dot xxx y.
Right.
And now it's gonna be 0.1, 0.1, 0.1, 0.2. So it just uses whatever component values.
Yeah, but what I got confused is that in that example, your color is a vector 4, but the u here is a vector 2, but it's being assigned y, 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 x, which is what...
Yeah, but x and y has the first two coordinates. It's not using z or w.
Yeah, it's...
If it was using z or w, it would make an error.
Oh, okay.
So, yeah.
Oh, so the c becomes a vector 4, but u is still a vector 2.
Yeah, it doesn't change.
You're just pulling from u.
You're just pulling the value that's in that position.
It doesn't change you. It doesn't change you. It's just whatever you assigned it to.
Gotcha.
So, yeah.